Welcome again to this video. In this video, I will explain the simulation of one Yagi-Uda antenna in same environment. So we'll open the software first. I'll get the license here. So you can use this license anywhere in our college if you are connected to the college Wi-Fi or the college LAN. You can install this software and you can use this in your laptop also, and just connect to college internet and you can access the license. So I'll press OK here. So what we'll do, we'll go to open project, and wherever our project file is there, we'll open that. So it is Yagi-Uda antenna. Double click here and open. So this is a Yagi-Uda antenna. Basically, what is a Yagi-Uda antenna? That it is a form of dipole antenna, but it has a directivity is higher here. So this is the green line you see here where my mouse is now. So this is the main antenna which is going to radiate, and the other things you are seeing here, this one, these three, so these are nothing but your reflector or directors, it is called. Okay, so the total setup is called as the Yagi-Uda antenna. So this antenna, the middle one, this one is going to radiate, and because of the other elements, the radiation pattern will be different. So in your dipole antenna, you have seen the radiation pattern is omnidirectional, but here it will be different. We'll see that. So before that, we need to run this one, simulate this one. So for that, we'll go to job manager, and here we'll start the simulation. Okay, so for that we need the software. Okay, so it now started the simulation. It takes a bit of time to simulate. Okay, it's completed and close. Then we'll go to see the results, what happened to the results. So we'll go to applications here, then for results we need to go to viewers. So once we are here, we need to import the results. So from where we'll import, so go to file, then import and plot. So here we have to select the folder where our antenna is there. So previously this file will not be there. Once you complete the simulation, then only this file will be generated. This is the result file you have to select, and after selecting you'll get this scattering matrix, and you can plot it here with 20 dB. So you see this antenna was designed at around 400 megahertz. So the value of the S parameter is not well below minus 10 dB, but it is close to that minus 10 dB. So you can say this antenna is resonating at this frequency, but this value should be below 10 dB. Okay, and after this we can plot the radiation pattern. So to see that radiation pattern, so what we can do, we can go to this contour that we have seen in the previous parts also. Here you have to select the spherical grid. That means to see the radiation pattern, I need a spherical structure in which I will see the radiation pattern. So I will select this far field, so it will give me the radiation pattern. Now you see here this antenna radiation style is changed here. Okay, so you see previously it was a omnidirectional antenna, right? Omnidirectional means you see this antenna was radiating means throughout this dimension. If this was the antenna, this was the length of the antenna, then it was radiating in whole this direction, all this direction of the antenna it was radiating. But right now it is changed and it is radiating in a particular direction. So that is why the directivity is increased here. So we can plot it by the gain. So previously the directivity was 1.5, and here now it is increased. For dipole antenna it was 1.5, but here it is directivity is increased by 3.5 dB now. Okay, so directivity, and we can plot the gain also. Both will almost same, and we can animate this for different frequencies. So once I click this animation, then it will animate the antenna for for different frequencies. Okay, so we don't need to know what is happening at other frequencies. So we should always concentrate what is happening in our resonant frequency, because that is the point where the maximum radiation is happening. So at the node we can see the electric wire current. So okay, so this is the wire current. You can see the pink area. So this pink is having the highest electric current. So this pink area means it is the main conductor, that is why highest electric current is there. And if we go to animate and at different frequency, you can see what is happening in other structures also. So you can see this is radiating, there is no physical port is connected here, but at resonating frequency when it comes, this also sometimes goes ping. That means it is actually okay. So see, so these are actually also working at other frequencies. If they are going ping, means current is also being generated there, and that is the reason why this behaves as a directional antenna, not as a omnidirectional antenna. Okay, so these are the two things you need to see in this Yagi-Uda antenna. So you have to plot this S parameter and show the radiation pattern and the current distribution also. Okay, so thank you.